So today we're going to look at solving quadratic equations using the quadratic formula, and we're going to focus today on real number solutions. For your central question, I want you to answer, why is the quadratic formula useful? So here we have standard form of a quadratic equation, y equals ax squared plus bx plus c. And here we have the equation y equals x squared plus 2x minus 1. Now I want to look at this equation graphically. So in order for us to graph this, we would need to find the vertex, x equals negative b over 2 times a, plug that back in to find the y value, and we would get a vertex of negative 1, negative 2. Now, we have seen solving using factoring. And so if y were equal to 0, we would be looking for those y-intercepts. And so if we were to try to solve this by factoring, using the x, if we multiply a times c, that would give us a negative 1. Our b value is a positive 2. Remember, your a value is the invisible number in front of the x squared. So there would be an invisible 1 here. We only plug numbers into the x. Now, the only factors of 1 are 1 and 1. And so if we were to use those two values, we would need to multiply them to get a negative, which means one of them would have to be negative. However, if we added them together, those are not going to add up to 2. So this equation here is not factorable. Now, there are going to be cases where we have to find the x-intercepts. Even if it's not a factorable equation, we have to have a method to find those x-intercepts. Now, notice here that this is the graph of this equation that I presented to you earlier, and the x-intercepts are these decimal values that clearly would not be factorable if we were to try to find them using factoring, because we get these decimal values. So what we would find here is that these are irrational answers. These are irrational x-intercepts, which means that there is a radical involved if we were to solve for it. So that being said, we have to have a method to solving quadratic equations when factoring is not an option or square roots is not an option, because this b value is present. So that is where we use the quadratic formula. Now, something I want you to recall is that we are going to use all of these different words to represent what we're looking for. So we refer to them as roots because there are square roots involved. They're solutions because we are solving for x. We refer to them as zeros because our equations have to equal 0, and because we look for those values when y equals 0, which are also the x-intercepts, which is when y equals 0. So the quadratic formula is going to be a little bit daunting at first, but the more we work with it, the more we use it, the more comfortable we're going to get with it. And it looks like this. So what we're looking for is the value of x when ax squared plus bx plus c is equal to 0. So we're looking for those x-intercepts when we use the quadratic formula, which means our equation has to be equal to 0. So our first step, again, is going to be to always make sure that our equation is equal to 0, because what we're looking for here are those x-intercepts. So keep in mind that we could have two x-intercepts in the case where our parabola intersects the x-axis as so. We could have one x-intercept if our parabola's vertex is on the x-axis. Or if our parabola does not intersect the x-axis at all, we would have no real solutions. And we would have imaginary solutions, which we did see with the solving using square roots method. We're going to leave that until our next lesson with the quadratic formula, though. So today I'm going to ask you to state the number of and type of solutions. So if we get 2 solutions with no i's, that would be 2 real solutions. If we get 1, that would be 1 real solution. And again, we're not going to see this today, but we will eventually find that there are no real solutions, but there will be 2 imaginary solutions. So let's take a look at how the quadratic formula works. So here we need to solve using the quadratic formula, write irrational answers, which means that we have a radical in our answer. We're going to write irrational answers in simplest radical form and as decimals rounded to the nearest hundredth. So we're going to do some work with our calculators today. And then for part B, I want you to write the number of and type of solution for each equation. So our first step here is to make sure that the equation is equal to 0, because remember, we're looking for those x-intercepts, so we want to make that equation equal to 0 so that y equals 0. From there, we want to identify the a, b, and c values of the equation. So for this equation here, it's in standard form. So a is equal to 6, b is equal to -11, and c is equal to -10. Don't forget those negatives, those are extremely important. Once we've identified the a, b, and c values, we can go ahead and plug these numbers into the quadratic formula. Something you want to make sure you're always doing is using parentheses when you do that substitution, especially with the negatives. It's so important to make sure that we don't forget about any of those negatives. So we are just simply taking our a, b, and c values and plugging them into the quadratic formula. So that's a negative parentheses b, which is -11, plus or minus the square root of b squared, so that's going to be a -11 squared, minus 4 times a, which is 6, times c, which is -10, divided by 2 times 6. Once we've plugged all of our values into the quadratic formula, we need to go through and simplify as much as possible. So little by little, a -11 is a +11. Inside the radical, we have -11 squared, which is 121. Now, this is where I see students make mistakes very often because they forget to use the negative when they square. So this is a -11 times a -11, which will always, always, always give you a positive number. So this first number inside the radical should always give you a positive once it's squared. The second, we have to just kind of deal with the negatives as we go. So -4 times 6 is a -24 times a -10 is going to give us a positive 240. So again, be extremely careful with those negatives. And in the denominator, we have 2 times 6, which is going to give us 12. So we simplify further. 121 plus 240 inside that radical is going to give us 361 over 12. Now, before you go to cake this radical, I want you to use your calculator to check to see if it's a perfect square. There's no need for us to cake it if it's a perfect square, and we have the access to a calculator to tell us that. So the square root of 361 is actually 19, and so that is a perfect square that we are able to go ahead and just rewrite as a whole number value. And in the denominator, we still have 12. So this plus or minus is going to give us two separate answers here. So at this point, we need to go ahead and separate this into two expressions so that we can simplify to find our values of x. So we have here 11 plus 19 divided by 12, and we have 11 minus 19 divided by 12. And so whenever we have that whole number value here, we're going to separate it and we're going to find those actual values of x. So we're going to simplify it as far as we can. So 11 plus 19 is going to give us 30. 11 minus 19 is going to give us -8. This should be a 12, not a 2. And we will always simplify our fractions as much as possible. So 30 divided by 12, or 30 and 12 are both divisible by 6. So that's going to end up giving us 5 over 2. And -8 and 12 are both divisible by 4. And that's going to give us -2 over 3. So our solutions here, our x-intercepts, are going to be at 5 over 2 and -2/3. But we're just solving, so we don't have to write them as ordered pairs. So x is equal to 5 over 2, and x is equal to -2 over 3. So that is the answer to part A of this problem. solve using the quadratic formula. So these are our solutions. For part B, we're being asked to write the number and type of solutions. So here we have clearly two solutions, and neither one of them contain i's, so these are two real solutions. And that is using the quadratic formula. All right, so let's go ahead and take a look at a couple more. So first step, make sure the equation is equal to 0. In this case, it is not. We must move the 1 over to the left-hand side. So that's going to give us negative x squared. When we subtract the 1, plus 2x minus 1 is equal to 0. Remember, you cannot combine the 1 with any of the other terms because it does not contain an x, therefore they are not like terms. From here, we need to identify a, b, and c. So a is equal to negative 1, b is equal to 2, and c is equal to negative 1. From there, we plug our numbers into the quadratic formula using parentheses. So we have a negative parentheses b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. From there, we need to go ahead and simplify. Negative 2 plus or minus. Inside the radical, we have 2 squared, which is 4. Then we have negative 4 times negative 1, which is a positive 4, times another negative 1 ends up giving us a negative 4, divided by 2 times negative 1 is negative 2. From there, we simplify. We have negative 2 plus or minus. Inside the radical, 4 minus 4 gives us 0, divided by negative 2. The square root of 0 is 0. So what we end up with here is negative 2 plus or minus the square root, plus or minus 0 over negative 2. Well, if you add 0 to negative 2, it still remains negative 2. If you subtract 0 from negative 2, it still remains negative 2. So this 0 can be eliminated because it's not going to affect our answer. So what we end up with here is negative 2 over negative 2, which is going to simplify to a positive 1. So we end up with just one solution here, which is x equals 1. So that means that our x-intercept here, if we go back to this equation here, our x-intercept where y equals 0 is at positive 1. And because there's only one solution, this indicates that the vertex is on the x-axis. For part B, state the number and type of solutions for each equation. Here we have one real solution. All right, let's go ahead and look at one more. Make sure equation is equal to 0. Well, notice in this case that our equation is in standard form and it's now set equal to y. So what we want to first make sure of is that we set this equation equal to 0. So if we are solving, we have to make sure that, as we stated over here, that it is when it is equal to 0. So we're going to go ahead and rewrite it as x squared minus 6x plus 6 is equal to 0. So we're solving for x-intercepts, and this is when y equals 0. Identify our a, b, and c values. A is equal to that invisible 1, b is equal to negative 6, and c is equal to positive 6. Go ahead and plug in to the quadratic formula. What I want you to do right now is go ahead and pause the video and plug your numbers in, and let's see how you did. All right, so let's see how you did. So x is equal to a -6 plus or minus the square root of -6 squared minus 4 times 1 times 6 divided by 2 times 1. From there, we need to simplify. So the -6 becomes a +6 plus or minus the square root. -6 squared gives us 36. Remember, that's a -6 times a -6. -4 times 1 is a -4 times 6 is a -24. And 2 times 1 is 2. From there, we simplify inside the radical. So we have 6 plus or minus the square root of 12 divided by 2. I'm going to go ahead and clear my screen to give me a little more space to work with. So at this point, we need to make sure that we simplify our radicals. So as I stated over here in the toolbox, there is a little bit more involved in this one because it is not a perfect square. So we have to make sure that we cake for the simplest radical form, because remember in the directions, it tells us to write it in simplest radical form and as decimals. So what we're going to do here is first simplify the radical. So we have to cake 12. So when we cake 12, we get 2 and 6, 2 and 3, and 3 and 1. So we're going to replace the square root of 12 with 2 radical 3. So we now have 6 plus or minus 2 radical 3 divided by 2. Now here, remember, we have this binomial in the numerator. And so in order for us to simplify this, again, we cannot simplify by just crossing off the 2's. So what we want to do is factor out the GCF from the numerator. Now we're not going to touch the radical because remember, we cannot divide the radical unless we have another radical. So we're looking at these outside numbers here to see if there is a greatest common factor. And 6 and 2 are both divisible by 2. So we're going to factor out that 2, and it's going to leave us with 3 plus or minus, and then 2 divided by 2 would give us 1 radical 3, which is just radical 3. Then at this point, we can now simplify by dividing these 2's out, leaving us with an answer of 3 plus or minus 3, the square root of 3. Now I want to go ahead and separate this though. So we have x is equal to 3 plus the square root of 3 and 3 minus the square root of 3. Showing our 2 separate answers. From here, we now need to calculate these. So in your calculator, you're going to type in 3 plus the square root of 3, however your calculator works. We talked about this in class. And we should end up with 4.73, rounded to the nearest hundredth. For 3 minus the square root of 3, if you type that into your calculator and round it to the nearest hundredth, you're going to end up with 1.27. So we write them as radicals because you'll often see them written that way, but the decimals are a more realistic way for us to view them because if we were to put these on a graph, these are the numbers that we would need to see on the graph. We don't see radicals on the graph. So for part A, these are our solutions. For part B, the number of and type of solutions here, well, again, we have 2 real solutions. And that is the quadratic formula with our real numbers.